All right, let's get into it. Today, we're talking about something that sounds like it was ripped straight out of a sci-fi movie. I mean, what if our most powerful computers aren't just crunching numbers here in our universe, but are actually working across countless other universes, all at the same time? Yeah, you heard that right. This is the big, mind-bending question we're tackling. Are quantum computers, these incredibly powerful machines, actually tapping into parallel universes to get their insane speed? It sounds completely nuts, I know. But this isn't just some fan theory. It's a question that some very serious physicists are actually grappling with. So, why is this conversation suddenly heating up? Well, it's all been supercharged by a brand new breakthrough from a quantum computer they're calling Willow. See, this isn't just a hypothetical thing anymore. Something real, something tangible has happened that's forcing these massive questions right into the spotlight. And what Willow pulled off? Wow, it's a huge, absolutely critical step forward. You have to understand we're on this long, tough road to building a truly practical quantum computer, one that can solve problems our best supercomputers today wouldn't even know where to start with. And this is a major, major milestone on that journey. So why should you care? What's the big deal? Well, this kind of power is a total game changer. We're talking about revolutionizing everything, creating codes that are literally unbreakable, discovering life-saving drugs in a fraction of the time, building climate models so accurate they could change how we protect our planet. This isn't just about a faster computer, you know? It's a peek into a completely different kind of future. Okay, so how on earth does a machine like this get that almost magical speed? Well, the answer might just come from a totally bizarre theory about reality itself. And trust me, this is where things get really, really interesting. It all kicks off with this fundamental idea in quantum mechanics called superposition. It's this super weird but totally proven concept that a tiny particle, like an electron, can be in multiple states at once. It's not heads or tails, it's kind of both at the same time, at least until you actually look at it. Now, the standard thinking is that the moment you measure that particle, all those other possibilities just poof, they vanish. But then along comes David Deutsch, a real pioneer in this stuff, and he asks this radical question. He says, wait a minute, what if those other possibilities don't disappear? What if they actually happen, just in their own separate parallel universes? And that wild idea is called the many worlds interpretation. The easiest way to think about it is with a coin flip. Okay, so while the coin is spinning, it's in superposition. It's both heads and tails. But the theory says that the second it lands, the universe itself splits in two. In our universe, the one we're in, it came up heads. But in another universe that just branched off, that exact same coin landed on tails. Both things actually happened. Okay, now take that coin flip idea and just scale it way, way up. Billions of times. The theory suggests that a quantum computer is basically outsourcing its calculations to billions of parallel universes simultaneously. Each universe tackles a little piece of the problem, and then somehow, the final combined answer pops back into our reality. I mean, wow. Now look, as incredible as that all sounds, I have to be clear. It's not the only explanation. It's not even the most popular one among scientists, to be honest. There's a much more, well, traditional and frankly less sci-fi way of looking at all this. So, this really brings us to two totally different ways of seeing reality. You've got the many worlds idea, where every possibility splits off and becomes its own real universe. And then you have the more classic Copenhagen interpretation, which says, nope. It argues those other outcomes were never real to begin with. They were just probabilities, just math, that all collapse down into one single reality the instant we observe it. So that's the bottom line, right? That's the crucial question. When a quantum bit gives us an answer, are we literally witnessing the birth of countless new universes? Or are we just watching a bunch of abstract math possibilities snap into one single concrete fact? That is the heart of the whole debate. And listen, this isn't just some philosophical debate for a late-night dorm room session. This is a real, active debate happening right now, and the scientific community is buzzing about it. Why? Because for the very first time, our technology might, just might, be getting good enough to actually test which one of these insane ideas is the right one. And that brings us right back to our friend Willow. Is this amazing machine literally reaching across dimensions, using the power of the multiverse to do its work? Or is it just an unbelievable master of probability, manipulating math in a way we've never imagined. The honest truth? We don't know. Not yet. But as exciting as all this is, it's time for a little reality check. We've got to be fair here. Not everyone is buying into the hype. There are plenty of skeptics out there, and they've raised some really valid points about what Willow actually did. So let's get specific about what this achievement was and what it wasn't. Willow didn't cure a disease or crack some impossible code. It solved a highly theoretical math problem, a random distribution benchmark. The best analogy I've heard is it's like a champion weightlifter lifting some ridiculously complex, perfectly balanced weight. It's an incredible demonstration of raw power and potential, but it's not the same thing as using that strength to, say, build a house. It proves what the machine can do, but those real-world applications, they're still a ways off. So where does that leave us? Well, the most honest answer is we just don't know for sure which way of looking at quantum mechanics is the right one. And you know what? That's what makes this whole field so thrilling. The fact that we might actually be on the verge of figuring it out, that's a huge reason why so many brilliant people are working on this stuff. And it all leads to this one final massive question to leave you with. Is it possible that our own technology, these weird, powerful machines that operate on the bleeding edge of what we even understand about reality, could they be the very thing that finally proves we're not alone, not in the universe, but in the multiverse?